Students, here we are going to have a question which is of set theory, and it is related with exercise 1.1. The question here it is, list all the elements of the following sets. Here x is such that x is an odd number, odd natural number. Now if we go through this question, now it is clearly mentioned here that x is such that x is an odd number. So what we have to do, we have to take its solution will be x a is equals to, now we can start with an odd natural number. It will be 1 3 5 7 and so on. Okay, now we will be having another one, that is b, x such that x is n minus 1 by 2 less than x less than 9 by 2, means the value of x is lying between 1 by 2 and 9 by 2. If we see 1 by 2, that is minus 1 by 2, that is 0.5 minus 0.5, and if we go with the 9 by 2, and if we go with the 9 by 2, what we are having? We are having 4.5. So the values which is less than minus 1 by 2 less than x less than 9 by 2, so we can have 0 1 2 3 4. Now here it is not mentioned that it is equal to. If it is equal to x, minus 1 by 2 less than or equals to x, then we can include this 0.5, and similarly if it is less than or equals to, then we can have 4.5 in this set. Okay, so this way we can go with the questions for set theory. Another question which is third one, and what we are getting here, it is c is equal to x such that x is an x square, is less than or equals to 4. Okay, now in this question what we are having, if we take x is an integer, now suppose if we are taking x which is equals to minus 1, x equal to minus 1, means its square is 1. Similarly if we go with the x is equals to say minus 2, its square is equal to 4. Similarly if we go for, now here it is mentioned x square is less than or equals to 4. Now if we go with this, we can include 0. If we are taking 0 square which is 0, which is also less than or 4, it is also less than or 4. 1 square which is also less than or equals to 4. If we go with the 2 square, that is 0 less than or equals to 4. Now if we go with this, if we are assuming here minus 3 square which is equals to 9, but if we go with 3 square which is equals to 9, which is greater than 4. So if we include in set C, I am writing it here, C is equals to, then it will be minus 2 minus 1, 0 also, 1 is also, and 2 is also, because here less than or equals to 4 means we can include this 4 also. So the set C which is x is such that x is an x square which is less than or equals to 4. Similarly the question 4 which we are having here, it is D 4 D, which is mentioned here X, such that X is is a letter in the word loyal, letter in the word loyal. So I am taking it here. D, if we are considering D here, loyal, now see here LOYAL, here repetition of only L is there, so D will be LOYA. This will be the answer of this question. LOYAL, loyal, the word which is included in this. Okay, so we can move like this. We will go with the next question. Here it is loyal that we can have. Here it is LOYA. Okay, now we will move for the next question. Now here it is an exercise of 1.2 set theory, and the question, which of the following are examples of the null set? Now if we go with the first one, set of all of odd natural numbers divisible by 2. Now you see odd natural number which is divisible by 2 is a null set. Why? Because no odd number is divisible by 2. No, if we are going with this 2 set of odd natural number, which is not divisible, because in this 2 is not divisible by any, so we can say it is a null set. It is a null set which has no elements. Second, set of even prime numbers. Now if we go with this, set of even prime numbers is also a null set, because 2 is an even prime number. 2 is an even prime number, so the answer is, it is a null set. Now we'll move with the next one, that is third question. X is such that X is a natural number and X is less than 5 and X is less than 7. Now if we see, X is such that X is a natural number, X is less than 5 and X is greater than 7, is again is a null set, because a number cannot be simultaneously less than 5 and greater than 7. So we can say here it is also a null set. Next question, fourth, which I am going to write it here. If Y is a point common to any two parallel lines, Y is such that Y is a point common to any two parallel lines. If we go this, parallel lines do not intersect. If we go with the parallel lines, which will be like this, and they do not intersect. So when they do not intersect, means there will be no common point. And when there will be no common point, so a point common to any two parallel lines is also so we can say it is also a null set. So this way we can have questions related to the set theory. Now question number 2, which of the following sets are finite or infinite? Now if we go with the set of months of a year, so in 1 year there are 12 months, Okay, means it is a finite, so we can say it is a finite set. Finite set number is countable, so we can say it is a finite set. Now next is 1 2 3 up to infinity. 1 2 3 and it is so on. Now here it is not mentioned, it is going up to a number which is infinite or uncountable. Uncountable. So we can say it is an infinite set. It is an infinite set. Similarly, the third one, here the numbers which is starting from 1 2 3 and going up to 100 means 1 2 3 up to 99 and 100, which is countable, means finite. So the set which contains such type of elements will be known as finite set. We can have like this. Okay. Now there will be next question for the set of positive integers greater than 100. Now see here, set of positive integers greater than 100 means if we start from more than 100 means 101, 100, then what will be the counting? It will be infinite, greater than 100, uncountable, means infinite, means we can say it is an infinite set. Okay, fifth, which is related with if we go with the fifth one, the set of prime numbers less than 99. Now if we see the set of prime numbers less than set of prime numbers less than 99, which is countable, means we can count it, so it is a finite, and we can say it is a finite set. It is a finite set. Okay, so here we can conclude with this question that we come to understand the finite set and infinite set. Infinite sets are those sets which have infinite elements, and finite sets are those sets which have finite elements. So this way we can differentiate finite and infinite set. In finite we are having a countable numbers, where in infinite sets we are having uncountable numbers. Okay. Now here state whether each of the following sets is finite or infinite. Again we are having the question. So if we go with this first, the set of lines which are parallel to the x-axis. Now if we go with the set of lines which are parallel to the x-axis, it is infinite. So we can say it is an infinite set. Infinite set. The next question, set of letters in the English alphabet. Now we know that set of in English alphabet is 26. English alphabets which are 26. So it is countable, means finite. Numbers are there, means it is a finite set. We can have this finite set. Now the third one, the set of numbers which are multiple of 5. Now if we go with the 5, the multiple of 5, that is 25, 10, 15, 25, 20, so I have taken only here 25, here maybe 10, 15, we can write it 10, 15, 20, 25, and this multiples of set which are having a multiple of 5, है ना? So again it is a infinite, infinite है, so we can say it is an infinite set. क्या होगा? It is infinite set. Now the next one, the set of animals living on the earth. Now set of living of animals which are living on the earth, that can be count. They are countable. Though the number is so large, but we can say it is a finite set. It is a finite set. Now the next, the set of circles passing through the origin 0, 0. Now if we can have an infinite, because infinite number of circles can be passed, so the answer will be infinite set, because what we are getting, infinite number of circles can pass through the origin. Okay. In next lecture we will go with the next questions which are related with the set theory. So watch these lectures.